Hey, sixth graders, welcome to 6.5. In this lesson, we'll be discussing the coordinate plane. And when I think of the coordinate plane, I think of that classic game that hopefully you got a chance to play as a kid. If not, man, you need to check it out because you're missing out. And that's Battleship. Because essentially, when you're plotting points in Battleship, now it's a little bit different because you're saying letters and numbers, but you're essentially graphing on a coordinate plane. Whether you knew it or not, this is what you were doing a few years back when you were playing Battleship, right? You'd put your battleships down here, and your opponent would try to hit them by guessing, and this would be your guesses. So the white ones would be misses, and the reds would be hits. So you've are looking to sink their ships. It's actually kind of a fun game, and it's actually a lot like graphing on the coordinate plane. So here we go. We'll go over some of the main ideas here to start. All right. Before, when you plotted points on a coordinate plane, like in fifth grade, I'm guessing you just dealt with positive numbers. And your graphs look like this. You went over, 5 up 2, and you put a point there, right? But really, you were only working in this first quadrant right here. And in a coordinate plane, we're dealing with all four. So we're dealing with this quadrant and also this one. And basically, all that is, let me just erase some of this. All a coordinate plane is a mix between a horizontal number line, kind of like the one you see in the front of the room, where we've got 0 and numbers that are positive are on the right-hand side and numbers that are negative are on the left-hand side, mixed with a vertical number line. And numbers that are above 0 are positive. Numbers that are below 0 are negative. Right? That's really all a coordinate plane is it's formed by the intersection of a horizontal number line and a vertical number line. The number lines intersect at the origin. Okay? The origin, let's circle this, is at 0, 0. Right here, this point is the origin. 0, 0 is the origin. And that's where the vertical meets the horizontal. And separate the coordinate plane into 4 regions called quadrants. Okay, notice this is quadrant 1, 2, 3, and 4. They're numbered with Roman numerals. And the way that I remember how to order my quadrants is I make the letter C. Start here, 1, 2, 3, 4. And that is the best hint that I can give you to remember the quadrant numbers. Okay, so letter C. 1, 2, 3, 4. I think that'll come in handy. A couple other things to point out. The vertical number line we call the y-axis. I've had students in the past remember that because the stem of the y is up and down. That's how they remember that the y is the vertical axis. And the x-axis is the horizontal. Right? You'll see it's marked right here. And the last piece of information that I'll give you is to find where certain points are located on this coordinate plane, you use what's called an ordered pair. An ordered pair is like directions. It tells you where you need to go on this coordinate plane. It's used to locate a point in the coordinate plane. For example, 4, -2. Always, 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 your x coordinate is listed first. And always, 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 your y coordinate is listed second. The way that I remember that is it's just alphabetical. So if I were to graph 4, -2, since 4 is positive, I go to where 4 is positive on the x-axis because my x is first. Start at 0, 1, 2, 3, 4, and my y-coordinate is -2, which means I would go down 2. And that is where that point would be. It's going to erase, isn't it? So 4, -2 will be right there. All right, there is a lot of information that I just gave you in one key idea. Okay, this is very important. I would write this down so you remember to look back when you're graphing, whether it's on an assignment or a quiz or a test. There's so many good tidbits of information in just this one key idea. So keep that in mind. All right, let's see what a few examples might look like. For our first problem, it says, identify an ordered pair. Which ordered pair corresponds to point T? Well, they've actually helped you out a little bit here because they've got a few lines. They're not always going to have lines in graphs, but just introducing this to you, I think they're using it to show you and help you a little bit. So here's point T, and what we need to think about for ordered pairs is, remember, our x is first and our y is second. Starting at 0, we had to go right 3, and you see that's represented with the blue 3. If I'm going right, notice my numbers are positive. So that would be +3. And then I'd have to go down 1, 2, 3. And going down represents a -3. So a 3, -3 would correspond with letter C there. Point T is 3, -3. So the correct answer is letter C. All right, do that same thing and try to locate these ordered pairs for 1, 2, 3, and 4 on your own. Pause the video now. Right, point P is right here. Starting at 0, always start at the origin. You have to go left 1, 2, 3. So left 3 would be -3. And we'd have to go up 1, 2, 3. So up 3 would be +3. -3, 3. It could go even further maybe, and it could ask you, what quadrant is that in? Well, make the letter C. 1, 2, 3, 4. It's be in quadrant number 2. Number 2, point Q is right here. X coordinate first. I had to go left 2. So left 2 would be -2. And up and down 0. I didn't go up and down at all. So -2, 0. If they asked you to describe the location of this point, it actually wouldn't be in a quadrant. It would be, you would say it'd be on the x-axis. Number 3, point R is right here. So starting at 0, I go left 1, which is -1. And I go down 1, 2, 3, 4. -4 when I'm going down. And lastly, for point S, that's right here, I go left and right 0. I'm not going over at all. I'm going up 2, which would be +2. The location of that point would be on the y-axis. So hopefully you did okay with identifying ordered pairs there. Let me know if you have questions. Right? For example 2 now, we get to plot. So it says plot -2, 3, and 0, -3.5, and describe the location of each point. You can see here that I've given you a little bit of graph paper, and here's our x-axis. I have that labeled, and here's our y-axis. Notice they have arrows on the end to remind you that they go on forever. Okay, you could add arrows here. And I'll plot A first, -2, 3. So I'm going to start at 0, negative 2 will be going left 2, and positive 3 will be going up 3. 1, 2, 3. This is going to be tricky. I got to figure out that setting. There's my point, and I'm going to label that A. Left 2, up 3 is point A. And then describe the location of it. Well, 1, 2, point A is in quadrant 2. And then letter B is 0, negative 3.5. So over left or right 0, so I'm going to be on the y-axis, and 3.5, negative. So down 1, 2, 3, and a half more would represent negative 3.5. Okay, so this would be point B. Describing the location of point B, that would be on the y-axis. It's between quadrants 3 and 4, but it's on the y-axis. All right, for 5, 6, 7, and 8, why don't you try to plot these ordered pairs in the coordinate plane? Pause the video and then come back to see if you got them correct. All right, number 5, 3, negative 1, over 3 to the right, down 1. I'm actually going to put a star here. Dang it, I thought that would not erase. Again, you can just put a point. I don't want mine to erase. Describe the location. That would be quadrant 4, or IV in Roman numerals. Number, let's see, number 6 here. We've got negative 5, 0. So 1, 2, 3, 4, 5 to the left, and up and down 0 would be right there. And the location of that is on the x-axis. Okay. Numbers, and sometimes too, it is helpful to label these. So, like if they had, like a letter next to it, like A, you would label this A, so on and so forth. They don't have them labeled here for you, but sometimes that can be helpful to do. Okay. Let's see what else we got here. We've got, for number 7, negative 2.5, negative 1. So that will be left 2.5, 1, 2.5, and down 1 would be right in this location. Okay. So notice how it's between grid lines. I can't get this one to stay for whatever reason. There we go. It's 1, 2, and halfway, and down 1. Okay, and that is in quadrant 1, 2, 3. Quadrant 3. And lastly, for number 8, I've got negative 1.5, a half. So negative 1.5, and then up a half. So right there. And quadrant number 1, 2. Quadrant number 2, 1, 2. So it's negative 1.5 and up a half. So sometimes those halves can be tricky, but again, just finding between about the lines. All right, let me know if you have questions. Example 3 is a finding distance problem. And this will be our last one that we do together. And then I'll leave you with a kind of a practice problem for the last graphing part of it. All right. It says an archaeologist divides an area using a coordinate plane in which each unit represents 1 meter. The corners of a secret chamber are shown in the graph. What are the dimensions of the secret chamber? So it wants us to find dimensions. That would be like, dimensions would be like how far or how long each side of this secret chamber is. So the length of the chamber is the distance between negative 4, 5 and 2, 5. Negative 4, 5 and 2, 5 right there. And the width is from 2, 5, the distance between 2, 5 and 2, 1. So right here. You can use absolute values to find the distances between the points. Well, you can pretty easily count too. 1, 2, 3, 4, 5, 6. This is 6 long, and that would be it's meters, and wide it would be 1, 2, 3, 4 meters wide. Okay, and it would be the same down here. 1, 2, 3, 4, 5, 6. 6 long and 1, 2, 3, 4 wide. So we could say the secret chamber is 6 meters long and 4 meters wide. Okay. And when they say you can use absolute value to find the distances between the points, that's like saying, okay, from this point to this point, from negative 4, 5 to 2.5, what is the distance from negative 4 to 2? Well, from negative 4 to 0 is 4, and from 0 to 2 is 2 more, so 4 plus 2 would give us 6. And notice that's the same we got for our distance of how long it was. And then for the width of the chamber, we go from 5 to 1. So 5 to 1 would be a difference of 4. And that's the same that we got there by just counting. So a couple different ways to do that type of problem. And either way will work for me. Whichever works best for you is good. But realize that when we graph something in the coordinate plane, then we can go a little bit further with that information and find the dimensions, or length and width. You could even find the area and perimeter of it if we wanted to. Okay, the last piece that you're going to work on is an activity today. This should be in the back side of your notes here. And it says work with a partner. You can, or you can do it by yourself. It doesn't really matter. Plot and connect the points to make a picture. Describe and color the picture when you're done. Right? It's important, guys, that you graph one of these at a time, and you graph them in order, and then connect the points. So for example, number 1 is 6, 9. I go over 6 and up 9, which would be right here. And then I'm going to go to number 2. And after I was done with number 2, I'd connect 1 and 2. So 4, 11, over 4, up 11. 1, 2, 3, 4 will be right here. And since I did 1 first, I'll connect 1 to 2. Now I'll graph 3, 2, 12, over 2, up 12. And I'll connect 2 to 3. So on and so forth. So sometimes it helps to cancel or to cross them out after you draw them. But you'll notice that there are 45 different points here. Right? It's going to take a little while, but it's good graphing practice. So connect those dots, those plotted points one at a time, and you're going to make a picture here in the end. Describe it and color it when you're done, and then come show me so I know that you've completed activity 3. Good luck with that, and that will do it for the notes on 6.5. Hopefully you learned something about the coordinate plane. Hopefully you're able to make that connection with the battleship. And if you have more questions, please let me know. I will see you next time.